The indexes that we've talked about so far are ones that you're likely to implement. In fact, you'll have some exercises on implementing them real soon. I want to talk about another kind of index, full text search index, that you're not likely to you're not likely to implement, certainly not in this class, but you should know the idea of it and you should know why we call it an index. So what is an index? An index has a sorted list of terms. An index refers to or categorizes or indexes an information base, and an index has a way of linking those terms back to the information base. Right, so let's take Google as an example. Google is a full-text search engine. Google uses a full-text search index to do its work. What is that index? That index is an alphabetical list of terms that is pulled out from web pages with links back into the web pages. What's the info base there? The World Wide Web. What's the alphabetical list of terms? It's sitting in some major data center of Google. How is that alphabetical list of terms able to get you back to the web page? Because each term has all the places on the World Wide Web. Believe it or not, this is a massive data structure, but it has all the places, and not on the World Wide Web, right? We all know that Google doesn't index the entire World Wide Web. Whatever percentage they're managing to index right now, it has for that whole percentage of pages all the instances of all of those words and where on the pages they are. So it captures all of that data. That data is, or that index is also, as I've said before, called an inverted file. And the idea of that inverted file is we take all of the files, all of the pages, all of the items that we want to index, and we shake them up and pour out all the words. And then we arrange those words alphabetically. But each time we arrange a word alphabetically, we maintain the information about where it was in the original file. The name of the file, and in case of Google, where on the World Wide Web that file was, and what position, what word position each of those words was. So as I say, that's a massive data structure. What we do then is when you issue a query, when you search, when you put a word, let's just say one word, into Google, it goes down its index, finds that word, and then says, oh, that word appears on these 5,357,264 pages. It figures out some way, and this is one of Google's secret sauces, some ways of saying which page should I show first and which page do I think is going to be most important. And then it produces a list of results. That list of results often, and the Google paradigm is for it to have the paragraph in which that word was embedded with that word highlighted. Now, if it's more than one word, the thing becomes more complicated, as you could imagine. If I have two words, what does that mean? Does that mean that it has to be one word directly followed by the other word? Well, that's what happens if I put quotes around them, but if I don't put quotes around it, what it ends up meaning really is those two words anywhere co-occurring in the same document, right? So we can go down a long trail of unpacking all that stuff, and I encourage you actually to take the other courses or to find out for yourself more about how that works, because it's an important subject, but it's really not the subject for this course. Really suffice it to say here that a full-text index is an index, just like the indexes we've talked about, and in fact you could simulate that if you really wanted to in an XML file, but there's far better ways of doing it than in XML. And the key concept is the alphabetical list of the words, all of the words that are in the full text of the items that are being indexed, alphabetized with links back to where they came from.